Stellar evolution is the life cycle of stars, which varies greatly depending on their initial mass. The journey begins in giant molecular clouds, regions filled with gas and dust, often called stellar nurseries. Within these clouds, gravity pulls gas and dust together, forming protostars. As they grow denser, the core temperature rises, eventually reaching millions of degrees, triggering nuclear fusion. Hydrogen fuses into helium, marking the star's arrival on the main sequence, where it will spend the majority of its life. This stage can last billions of years, with the star in a balanced state, radiating energy outward while gravity pulls inward. When hydrogen fuel in the core depletes, a star leaves the main sequence. For a sun-like star, this transition leads to the red giant phase. The star expands as fusion shifts to outer layers, creating heavier elements like carbon and oxygen. Eventually, the outer layers are expelled, forming a glowing shell called a planetary nebula. What remains is a white dwarf, a dense core that cools over billions of years. In some theories, it's thought white dwarfs might eventually become black dwarfs, though the universe isn't old enough for any to have formed yet. Massive stars, however, follow a more dramatic path. After leaving the main sequence, they expand into supergiants. In their cores, temperatures soar high enough to fuse elements far heavier than carbon, eventually forming iron. But fusion of iron requires more energy than it produces, leading to a catastrophic collapse. This collapse triggers a supernova explosion, an event so powerful it can outshine an entire galaxy. The explosion disperses heavy elements like gold, silver, and uranium into space, enriching future generations of stars and planets with essential building blocks. The remnant of a supernova explosion depends on the mass of the original star. For stars slightly more massive than our Sun, the leftover core may form a neutron star, a dense, compact object where atomic nuclei are squeezed together, creating neutrons. Some neutron stars become pulsars, emitting beams of radiation detectable on Earth. In the case of extremely massive stars, the core may collapse further, creating a black hole, a point of gravity so intense that not even light can escape its grasp. Stellar evolution not only determines the fate of individual stars, but also plays a crucial role in cosmic evolution.